Today we're learning about something that you should have already touched on in middle school called GCF, or greatest common factor. And when I'm looking for the greatest common factor, I'm essentially going to list out all the factors, all the numbers that divide 18. So 1 and 18, 2 and 9, 3 and 6, all those numbers divide 18 evenly. Same thing with 30. 1 and 30, 2 and 15, 3 and 10, 5 and 6. All of those numbers can divide my original number, or are factors of. 1 and 2 are common factors between them. 3 is another common one. 6 is another common one. But my greatest common factor between the two sets is 6. So my greatest common factor between 18 and 30 is 6. What we're going to look at is more complex. We're looking for more, how do I now find a greatest common factor when I have variables? Well, if I were to list out the factors of y to the fifth, it would look like this: y times y times y times y times y, 5 times. Same thing with y to the third, I would have 3 y's multiplied together. And y to the seventh, I would have 7 y's multiplied together. Those are my factors of each of those things. Well, what do they have in common? They all have y's, right? And they all actually each have at least 3 y's. All of them have at least 3 y's. So my greatest common factor between those sets of variables is actually y to the third power. So the rule we're actually going to write down for ourselves is the fact that the GCF of a set of variables is simply just the variable with the lowest exponent. The lowest exponent. So make sure you write this down. The GCF of variables is the variable with the lowest exponent. So if I look at that next example where it has x to the fourth, x and x to the second, my second example, my GCF between those 3 terms is in fact x, my term with the lowest exponent. And we're going to use this to do a lot of division. But first, let's practice finding the greatest common factor just a little bit more. So if I were to find the greatest common factor between 40 and 10, I would list out all my factors of 40. So 1 and 40, 2 and 20, 4 and 10, 5 and 8, and all my factors of 10, 1 and 10, 2 and 5, and I look at that list, and the greatest common factor between them, my GCF, is 10. My biggest one is 10. Try and do that for number 2 and 3. Check your answer in just a few moments. Go ahead and pause your video. Between 54 and 45, my GCF is 9. And between 12 and 44, my GCF is 4. Now let's look at the other greatest common factor problems. Number 4, my greatest common factor, I'm looking for the variable with the lowest exponent. Lowest exponent. So my greatest common factor is x. And in number 5, my greatest common factor is y to the second power, my one with the lowest exponent. And when I'm looking at number 6, my greatest common factor, well, if I were to look at just the variables, x to the third, x, and x to the square, x to the second power, my greatest factor is x. However, then I also have to look at these numbers, my coefficients in front, 15, 25, and 45. Out of those, my greatest common factor is 5. So my total GCF is 5x. And we're going to use this, and we're going to essentially factor or divide out a greatest common factor from the following polynomials. So for this very first one, I'm looking at my numbers 18, 15, 3, and 6. What's my greatest common factor between just those numbers? 18, 15, 3, and 6. Well, they all can be divided by 3. So that's exactly what I'm going to do. I'm going to write this little upside down division sign and put a 3 outside. 18 divided by 3 gives me 6, y to the fourth. Negative 15, y to the third divided by 3 is negative 5, y to the third. 3 divided by 3 is just 1. It's going to simply cancel or go away, but you can write down the 1 if you want to. And negative 6y divided by 3 is negative 2y. So that's factoring out a number. Now let's factor out a variable. If I'm looking at my y to the fourth, y to the third, y to the second, and y, my greatest common factor out of those variables is my lowest exponent, or in other words, y. I'm going to divide all of these pieces by y. And if you recall from the beginning of our quarter, when we started learning about y to the fourth divided by y, when I divide with variables, I have to remember that I actually divide means I subtract my exponents. So y to the fourth divided by y is actually y to the third power. So when I take 6y to the fourth divided by y, I get 6y to the third power. 5y to the third divided by y, I get 5y to the second power. 1y to the second power divided by y, I get just plain old y. And 2y divided by y, my y's are actually going to cancel out, so I'm left with just -2. And so my final answer, I'm going to write all of this out in one parentheses. I'm going to have 6y to the third minus 5y to the second plus y minus 2 in parentheses. And this stuff that I divided out, 3y, is going to go outside my parentheses. So I have my simplest form inside my parentheses and my factor outside my parentheses. That is my final answer. So let's look at number 1 at the bottom of the page. 34, 8, and 16. My greatest common factor between those three numbers is actually just 2. So I'm going to divide by 2. So 34 divided by 2 is 17. 8 divided by 2 is 4. And 16 divided by 2 is 8. And then if I'm going to look at my greatest common factor of just my variables, I'm actually going to look at just the lowest exponent, which is x to the second power. So let's divide everything by x to the second power. In other words, subtract 2 from every single exponent. So I'm going to get 17x to the second minus 4x, because x to the third divided by x to the second just gives me x, and plus 8, because 8x to the second divided by x to the second, those x to the seconds cancel out. So my final answer, I'm going to rewrite that in simplest form at the bottom in my parentheses, and that 2x to the second goes outside my parentheses, and that is my final answer. Now let's look at number 2, 45, 27, and 18. That greatest common factor for those is 9. They can all be divided by 9. So 45 divided by 9 is 5y to the third. 27 divided by 9 is 3y to the second. And 18 divided by 9 is 2. Now looking at just my variables, my y's, y to the third, y to the second, and y, my greatest common factor out of those is my lowest exponent, just plain old y. So let's divide everything by y. I'm subtracting 1 from every exponent on my y because I'm dividing by y. So 5y to the third divided by y, we get 5y to the second power. 3y to the second divided by y, I'm going to get -3y. And 2y divided by y, those y's again are going to cancel out, and all I'm going to have left with is 2. So my final answer is at 5y to the second minus 3y plus 2, all in parentheses, and my 9y goes outside of my parentheses. And my final answer. Last example, number 3. Looking at 32, 16, and 8, my greatest common factor for those is 8. So I'm going to divide everything by 8. 32 divided by 8 gives me 4. I'm going to leave the variables the same. 16 divided by 8 is 2. Again, leave your variables the same. And 8 divided by 8 is 1. Again, leave your variables the same. But now we have an x and a y. So let's look at just our x's. X to the fourth, x to the third, and x to the second. Out of those, my greatest common factor is going to be x to the second. So I'm going to divide all of these by x to the second. I'm only dealing with the x's. So my 4 is going to stay exactly the same. However, now instead of x to the fourth, I'm taking x to the fourth divided by x to the second, subtracting 2, and I get x to the second. my y is going to stay exactly the same. 2 stays exactly the same, and x to the third divided by x to the second gives me just x. My y stays exactly the same. And lastly, my x to the second divided by x to the second, that kind of cancels out. All I have left with is 1y. But I also have a y in every single term. I have y to the second, I have y to the third, and I have y. So I also need to factor out a GCF of my y's. My greatest common factor between those is y. So let's divide everything by y. So when I divide everything by y, I'm only dealing with the y's. I'm subtracting 1 from each of my y's. So my answer here, 4x to the second stays the same, but y to the second divided by y gives me just plain old y. Minus 2x stays the same. Y to the third divided by y gives me y to the second power. And lastly, 1y divided by y, I am left with just plain old 1. So my very final answer at the end of everything, once I've factored it all out, I have all of my simplified form in my parentheses, and everything that I divided out, 8 x to the second y, all goes outside of my parentheses. My greatest common factor goes outside. Your assignment today is to do that double cross, that riddle activity. And it's only 14 problems, but please show your work on a separate piece of paper. Show your work.